8 minutes after the sun vanished, daylight would die. For those 8 minutes, Earth would feel perfectly normal. By vanished, I mean gone, no light, no gravity influence. Both changes reach us at light speed, not instantly. The clock starts the moment the last photon leaves. Here's what unfolds minute by minute once darkness arrives. The immediate takeaway is simple: timing controls everything that follows. Bright noon hangs over fields and streets, everything looks ordinary. Cars hum, shadows sit sharp, and nothing screams emergency yet. This lull is real, not a trick of wording. Nothing from the sun has reached you informing otherwise. Light and gravity travel at the same cosmic speed. Until that wavefront arrives, physics keeps playing yesterday's tape. Rule of thumb: no signal means no change you can test. Your phone works, satellites whisper, and power grids hum along. Tides are still mixed by the moon and sun together. Airplanes follow routes that were planned a day earlier. Birds chase thermals that still rise under warm patches. Your skin feels the same radiation it felt before. Quick example in real terms: sundials still cast neat lines. 8 minutes later, that shadow game ends without warning. Emergency services would not pre-alert because instruments see continuity. There is no forewarning crackle, siren, or early twilight. It feels mundane on purpose because information has not arrived. Bottom line, the quiet before darkness is genuine and measurable. Clocks disagree nowhere because relativity keeps causality ruthlessly local. So you glance up, blink, and shrug at the sky. No countdown appears, and yet the countdown is already running. Those last sun photons are mid-flight, racing toward your face. Then the wavefront hits and daylight snaps to black. At that same heartbeat, the sun's pull switches off. Gravity's changes travel at light speed, not some magic faster. Why care? Because our orbit stops bending and goes straight. Earth has momentum, about 30 kilometers per second sideways. Without the sun's curve, we keep that direction relentlessly. Picture a stone released from a sling, flying tangent. Same deal here, only the sling was nuclear fusion. In one day, we drift about 2.6 million kilometers. In 1 year, roughly 1 billion kilometers from our old track. Seasons vanish instantly because seasons are angles to sunlight. We keep our tilt, but there is no beam to meet. Satellites feel the same cutoff, their orbits around Earth persist. The whole solar system unthreads, each planet shooting its tangent. Common mistake is thinking we fall inward faster. We do not. The falling has ended at that instant. Example in real terms: Voyager would suddenly lose the headwind. Net result: Earth becomes an interstellar traveler with home decor. Our nightside stops warming and our dayside stops existing. Radiation pressure drops to zero, but momentum rules anyway. Navigators would draw straight lines, not ellipses, for paths. So the picture is motion unchanged, curve removed forever. Streetlights pop on, but their cones feel swallowed by space. The moon fades to black within minutes, then never returns. Planets vanish too, because they only shine by reflection. Skies that were blue turn velvet, speckled with hard starlight. A million faint suns stare back, unwashed by daytime glare. Why this matters: our eyes lose orientation and emotional anchors. Human circadian rhythms drift without sunrise cues, sleep gets weird. Photons stop arriving, so heating stops and cooling begins. Air immediately grows clearer, but also colder with time. Auroras fade after hours because the solar wind disappears. Cosmic rays still strike, guided by Earth's magnetic field. Example: daylight measures about 100,000 lux at noon. Full moon gives about 1 lux, which now also vanishes. Starlight alone is around 0.001 lux. City blocks outside power grids would feel like deep caves. Tiny test: walk under a new moon night in winter. That darkness is still 10 times brighter than starlight only. Bottom line, the sky resets to ancient night and deeper. Navigation shifts to radio beacons because horizon cues evaporate. Astronomy becomes glorious, while daily life turns profoundly disorienting. Waves still heave, but the rhythm loses its second drummer. The sun was a big tide maker, almost half strength. With it gone, lunar tides remain and ranges shrink. Harbors that saw spring surges now calm by about 1/3. Why this matters: coastlines breathe differently and currents reorganize. Storm surges ride new baselines, changing flood risk patterns. The moon itself keeps orbiting Earth, bound by our gravity. Months keep their length, but the moon goes pitch black. Eclipses stop permanently because there is no sunlight geometry. Mechanically, tides are gradients, not simple pushes and pulls. Remove the sun and the gradient halves near coastal shelves. Example, Bay of Fundy highs could drop by several meters. Surf spots lose consistency, while some slackwater windows lengthen. Fisheries follow because plankton blooms ride light and tides. Ports would rewrite schedules, pilots would retrain, and maps change. Rule of thumb, less springiness means fewer extremes but surprises. So the picture is tides persist, with sun-made silence. Long tidal resonances inside bays would slowly retune themselves. Some estuaries might clear, while others trap silt more persistently. Bottom line, water keeps moving, but the metronome loses weight. Heat starts leaking to space like cash from a hole. The ground radiates infrared and nothing balances it anymore. Why care? Because comfort clocks run out shockingly fast. Within hours, temperatures dip a few degrees across many regions. After a day, expect 10 degrees colder in many cities. About a week later, global averages approach -20 Celsius. Oceans release stored heat, delaying the plunge on coasts. Continents cool faster, deserts crash hard during long nights. Atmosphere still circulates, powered by leftover gradients and rotation. Winds sharpen for weeks, then slowly weaken as contrasts shrink. Example numbers: a typical home loses heat around 5% hourly. Insulation buys time, but fuel becomes the new sunshine. Rule of thumb, double your insulation and have your burn. After a month, average temperatures drop toward -30 Celsius. After a year, many models settle near -40. Long-term, Earth radiates down near 3 to 30 Kelvin. That takes centuries to millennia, thankfully buying planning margins. Bottom line, the thermostat tumbles steadily, with oceans cushioning early. Power plants struggle with coolant icing on exposed intakes. Grid operators juggle blackouts, rationing heat as reserves slide. Greenhouses switch to LEDs, turning electricity into crop lifelines. So the picture is rapid cooling first, then a crawl. Sea smoke curls off black water, then a crust forms overnight. Polar oceans glaze first, then mid-latitudes follow within weeks. Ice thickens from the top, trapping liquid warmth below. Why that matters: oceans become insulators, not just freezers. Geothermal heat seeps upward, keeping deep water above freezing. Researchers estimate liquid oceans could persist for millions of years. Sea ice might reach tens to hundreds of meters thick. Surface travel becomes sled routes, while subsurface craft still swim. Atmosphere changes in strange, beautiful, and scary ways. Water vapor collapses into snow, then dwindles as air dries. Carbon dioxide deposits as dry ice near the poles. Oxygen and nitrogen mostly remain gaseous at these temperatures. Only far later, at brutal extremes, would they liquefy. Example, Antarctic stations already see -80 on rare nights. With no sunrise, that becomes normal across high cold basins. Rule of thumb, first the seas skin over, then climate simplifies. Bottom line, a frozen shell hides a living, black ocean. Snow dunes grow tall, sculpted by katabatic winds off plateaus. Coastal cities entomb under rime, their towers wearing hoarfrost. Shipping stops forever, replaced by creaking ice highways between continents. So the picture is white silence above, dark water below. Earth now coasts through interstellar space, a house untethered. Stars crawl by unbelievably slowly because distances are monstrous. Why this matters: outside forces are rarer than you fear. Jupiter and friends also shoot off, no longer circling anything. We will not smash into Jupiter, trajectories have parted. Nearby stars tug slightly, but those threads are hair-thin. A passing star could deflect us, given enough proximity. Statistically, that may take millions to billions of years. Interstellar gas is sparse, so drag is practically zero. Our magnetosphere swells without the solar wind compressing it. Cosmic rays still drill in, guided by those magnetic lines. The core keeps spinning, so our field keeps standing. Example, at 30 kilometers per second, we cross 1 light year. That takes about 10,000 years, which feels like eternity. Stargazing becomes exquisite because no sunlight drowns faint nebulae. Navigation favors pulsars because they tick like cosmic lighthouses. Rule of thumb, momentum rules today, gravity whispers from afar. Bottom line, we drift for ages, mostly untouched by neighbors. Micrometeoroids still pepper satellites, but shielding handles the flex. Deep space truly is empty, not crowded like movie scenes. So the picture is loneliness, with time stretched absurdly long. 8 minutes of normal, then a universe with new rules. That's the part that startled me most, the quiet countdown. Everything that follows is physics, not doom for its sake. We would drift, freeze, adapt, and probably write new myths. If this mind trip clicked, stick around for more curiosities. Next time, we pick another thread and pull carefully. Bottom line, timing rules reality and stories help us prepare. Thanks for hanging out in the dark with me. See you soon, hopefully under friendlier stars.